Hello again, statistics students. I'm trying a different screencast software. Hopefully it'll be okay. The sound may not be perfect, so turn your audio up as far as it can go. We're going to work on two problems, problems 83 and 84 in your homework for chapters 6 and 7. So once again, we're going to work on problems 83 and 84 in the homework for chapters 6 and 7. These, these questions are about confidence intervals for the population proportion. So problem number 83 reads, translate the statement into a confidence interval. Approximate the level of confidence. I believe number 84 is very, very, very similar. In a survey of 1,068 adults in a country, 77% said being able to speak the language is at the core of national identity. The survey's margin of error is plus or minus 3.8%. The confidence interval for the proportion is, okay, so first of all, n is equal to 1,068, p is equal to 0.77, q is equal to 1 minus p, and I believe that is 0.23. Okay, and the margin of error is equal to 0.038. So my confidence interval is simply going to be p minus margin of error, p plus margin of error, and those numbers are 0.732 and 0.808. 0.732 and 0.808. So let's see if Pearson agrees. Great, Pearson agrees. So that's the correct confidence interval. Now we have to figure out the percentage of the confidence interval, and that's a little bit more work, but it's not that difficult. So we're going to use Mathematica's solve command. We need to use the right formula, okay? So solve, solve margin of error is equal to, so notice I use the double equality symbol. I'm not using the single equality symbol. I'm using the double equality symbol. And that is going to be z. I'm going to make up this, well, I need to find a z-score. So I'm going to use the variable z, or the letter z, times, I don't need to really type the multiplication symbol. A space in Mathematica, if I just enter a space, that's the same thing as multiplication in Mathematica. Control 2, p times q, shade this whole thing, highlight it with my cursor, control divide by, so I'm highlighting p times q with my cursor, control divide by n, okay, and then I'm looking for z. What is z? And I know I'm going to get a nested list of lists. I just want one list. Okay, so my solution is equal to, shift enter. Okay, z is approximately 2.95. So what I'm going to do is define a variable z. Z is equal to z as it's defined in my solution. So z is equal to 2.95. Okay? And the next is very simple. CDF, normal distribution, 0, 1, positive Z, minus CDF, normal distribution, 0, 1, negative Z. I'm sorry, negative Z, not negative 1. Okay, so 0.9968, and it says here round to 1 decimal place is needed, so you guys should remember how to do that. Number form, CDF, normal distribution, 0, 1, Z minus CDF, normal distribution, 0, 1, negative Z. Okay, infinity means give me all the digits to the left, although we know it's really just going to be one digit. And I want one digit to the right of the decimal point. So infinity means give me all the digits to the left of the decimal point. The 1 here means give me one digit to the right of the decimal point. That did not, wait a minute. Why am I just getting the number? This is really the correct answer here. That's really strange. So this did a little bit too much rounding. Okay, well, we're going to use this value up here. Okay, this did a little bit too much. This did a little bit too much rounding. Okay, the interval is a 99. Wait a minute. No, yeah, we'll just use this value up here. For some reason, this isn't really working as expected, but that's okay. So the interval is a 99.7% confidence interval. Okay, which is correct. Okay, so I simply rounded this out. Hold on one second. Oh, you know what the problem? Okay, what the problem is? Yeah, this whole thing needs to get multiplied by 100 to turn it into a percentage. There we go. Okay, yeah. Excuse me. So if you want to change something, if you want to change a decimal value into a percentage, if you want to change a probability into a percentage, you have to multiply by 100. So that's what I did not do. Okay, so, well, I did it now. So, 100 times. Okay, so, yeah. Okay, so 99.7%, 99.7%, that's the percentage of confidence. I have a 99.7% confidence interval. Okay? Excuse me, I just have some congestion. I'm actually feeling fine, but I have a little congestion going on. Okay, number 84, I believe, is very similar. However, I would like to clear all of these variables. Actually, just let's say remove them. I want to remove these variables from Mathematica's memory because I want to redefine them. So remove global, the tick mark in the upper left of my computer keyboard, times, okay, shift enter. So now, the variables above are no longer defined. Z doesn't have a definition, P doesn't have a definition, Q doesn't have a definition, solution doesn't have a definition. So these variables are undefined. They're undefined. I removed them so that I can reuse them and redefine them for the next problem. Okay, again, number 84, very similar. Translate the statement into a confidence interval. Approximate the level of confidence. In a survey of 1,000 adults in a country, 65% think teaching is one of the most important jobs in the country today. The survey's margin of error is plus or minus 4%. So the confidence interval for the proportion is, okay, so P, the proportion, is 0.65, right? Margin of error is 0.04, okay? So my confidence interval is P minus margin of error, okay, and P plus margin of error. Okay. Yeah, so Mathematica sometimes does that with, it shows a lot of extra zeros. That's not really a Mathematica problem. That's actually a machine arithmetic problem. All right, so we can, change that. Number form, confidence interval. Number form is cool. It doesn't just work on numbers. It works on lists of numbers, which is really nice. Infinity, and then 3 decimal places, because Pearson wants 3 decimal places. Okay, so that was nice. 0.610 and 0. Let's try that again. 0.690. 0.610 and 0.690. Okay? So if I sample 1,000 adults in the country, right? And if I keep doing that, I keep looking, I keep looking at different samples of 1,000 adults. That means, so most of the time, the percentage of people who think that teaching is a very important job, that percentage is going to be between 61% and 69%. It may not always be exactly 65%. There's going to be some variability because different people have different opinions. Okay, so, and then we have to figure out the percentage of confidence, okay, which should not be that difficult to do. Okay, that's correct. So what is the percentage of confidence? Okay, so again, we're going to use Mathematica's solve command. Margin of error, which is what is that, 4%? I could simply type 0.04. But we've already defined margin of error to be equal to 0.04. So why don't I simply use the name of the variable? Margin of error, which is 0.04, is equal to z control 2 PQ. Did I define PQ? Let me see. You know what? I did not define. I defined P. I did not define Q. Q is 1 minus P, which is 0.35. Okay. Highlight PQ. Control divide by N. And you know what? I didn't define N either. N is equal to 1,000 people in my sample. All right. Oops. Here we go. I'm looking for Z. Flatten. Okay, Z is about 2.65. 2.652, something like that. Okay, so then the rest is easy. CDF, normal distribution, 0, 1. Z minus CDF, normal distribution, 0, 1, comma, negative Z. And I want to round that out to 1 decimal place. Let's see if this will work. Sometimes this Mathematica trick doesn't work, but sometimes it does. 1 decimal place. Oh, hold on 1 second. Okay, why is that not? Oh, I see what's going on. I didn't define z. Z is equal to z as it's defined in my solution. So now z is that number. Aish. Hold on. Let's try that again. Why is it doing... You know what? Hold on one second. Let me get rid of round. I think I know exactly. Okay, I'm having the same issue as before. I need to... okay, here we go. Here we go. Let's just do that. Okay, so once again, so it's going to be 99.2. Okay, 100 times to make it a percentage, rounds it out to 1 decimal. Yeah, 99.6. So again, I'm getting way too many zeros. So it will make more sense for this problem to use number form 100 times. Oh, no, I see what's wrong. I need to use parentheses. I need parentheses. Hold on one second. There we go, 99.2. Or I could use number form CDF normal distribution 0, 1z minus CDF normal distribution 0, 1. Negative z, close parentheses, infinity, and then 1 decimal place because Pearson is requesting that. And again, I should get the right answer. So 99.2%. Okay, so let me explain something because this is the interpretation is really important. What this actually means is this: if I survey 1,000 adults in this country, okay, and it doesn't have to be the same 1,000 adults. It could be a different group of 1,000 adults. It could be a different sample of 1,000 adults. So I keep on, looking at different groups of 1,000 adults. I keep sampling different groups of 1,000 adults. And I do this over and over and over and over and over again. I keep looking at different groups of 1,000 adults, okay? 99.2% of the time, the percentage of people in those groups who think that teaching is one of the most important jobs in the country today, the percentage is usually going to be between 61% and 69%. And that should be true about 99.2% of the time. So 99.2% of the time, I expect between 61% and 69% of those 1,000 people to believe that teaching is one of the most important jobs in the country today. It's not going to be 65% every single time for every single sample of 1,000 adults because different groups are going to be a little bit different. Different groups of people contain different people who have different opinions. But in general, about 99.2% of the time, that percentage will fall in between 0.61 and 0.69. Or in other words, between 61% and 69%. Okay? I hope this made sense. I hope you understand what's going on. So hopefully you guys are getting it. I realize this is kind of a poor substitute for a lecture. I think a lecture is better. Meeting twice a week at Oakton College is certainly preferable to these video lectures. But hopefully you're getting something positive from the video lecture, okay? So anyway, and hopefully you're getting something positive from watching me use Mathematica. All right, so I hope that you're getting something out of it, okay? Other than a headache. So anyway, take care, and let me stop the video. Okay, how do I stop this video? Here we go. Finish recording. Okay, great. Everyone have a fantastic day. And yeah, this is a bit confusing. I'm using a different screencast software, and I'm also using a different laptop, so it's a little bit confusing. Okay, guys, have a great day, and hopefully you're all safe and healthy, and that's about it. Take care, and good luck with your statistics studies. If you have questions, please email me, and I'll try to get back to you as soon as possible. All right, be well. Bye-bye.